Section 2.3, Part 2. We're looking at domain and range and function. We looked at ordered pairs. Now what we're about to do is, I'm going to draw a bunch of graphs in just a few minutes. And we're going to do domain and range and function by looking at graphs. It's the same concept, but it's worked completely different. So I'll give you what notes you need here in just a second. Before I do this, I want you to just watch. I don't want you to, you don't have to write any of this down. I just want to show you something here. All right, so let's look at this graph together. So let's suppose I had a graph that started right here and went all the way to over here. No arrow on this graph, so it doesn't go on forever. If it did, that would change some things. But let's just look at just this graph. Starts here and ends right there. First thing I want to say is this, because sometimes students think this. I've asked students in the past, how many points is on this graph? And they'd say 4. And they say 4 because they see these 4 bubble points right here. There's not just 4 points on this graph. There's billions. There's billions of points all along here. So just because I bubble these doesn't make them more important. I'm bubbling so you can see them. But there's a point here, a point here, a point here, a point here. So there's millions of points all along this line when you look at a graph. So any portion of a graph is just millions of infinitely number ordered pairs infinitely close together. So there are billions of ordered pairs on this graph. So the reason we have to change our thinking is this. Domain is all of the first numbers. Well, my heavens, if there's billions of points all along these ordered pairs, I can't write out all those first numbers. But I can still represent them by way of if it's a certain select group of numbers. So let me show you what I mean by that. All right. Let's look at this first ordered pair right here. Now remember, there's millions, but let's look at this first one. If I wrote this ordered pair out, it would be 2 comma something, wouldn't it? So that ordered pair has a first number of 2. This ordered pair has a first number of what? 3. This ordered pair has a first number of 4. This ordered pair has a first number of 5. So for sure, the domain uses 2, 3, 4, and 5 because that's all of those first numbers. But if you move over just a little bit, it uses like 2.1 and 2.2 and 2.3. So wouldn't it be fair to say all of these points uses all the numbers between 2 and 3? All of these points uses all of the numbers between 3 and 4, and all of these points uses all of the numbers between 4 and 5. So the domain is not just 2, 3, 4, and 5, because the graph is solid. The domain is every number between what? 2 and 5. I'll give this to you in a note in just a minute. So wouldn't it be fair to say this? The domain is how far the graph goes from left to right. So look at where the graph starts. Look at that X number. And look at where that graph ends. Look at that X number. So it's how far you go from left to right. I'll give that in a note in just a second. Now, so the domain is everything from 2 to 5. And remember, in algebra, when we put the brackets on the 2 and 5, that means you're including the 2 and you're including the 5. Now, what is the range? The range is all of the y values, or the second numbers. So, if I look at this ordered pair, right here, this would be the ordered pair, 2, comma, 1 would be that ordered pair. What would this right here be? 2, comma, 2. So this one has a y value of 1. This one has a y value of 2. Now, what about all of these? Well, it's going up. So you're using all of the numbers up from 1 to 2. So the range is not 1 and 2, it's every number from 1 to 2. So then it turns out that the range is how far the graph goes from the bottom up to the top. You're looking at your y numbers instead of your x numbers. So the range here would be everything from 1 to 2. All right, so let's take these two notes down. And I'm actually going to give you the third note, which is going to make absolutely no sense until you copy it. I will explain in just a minute what it means. Here's the three notes. Note number 1. The domain of a graph is how far the graph goes from left to right. It's how far the graph goes from left to right. The domain of a graph is how far the graph goes from left to right. And that's what we just said right here. It starts at 2, ends at 5, and it uses all the numbers between 2 and 5. Second part of the note. The range is how far the graph goes from the bottom to the top. Now the last part. Third note. A graph represents a function if it passes the vertical line test. Now, what does that mean? I'll show you, let's write this down. Continue the note. If every vertical line that can be drawn intersects the graph at most once, we say that the graph passes the VLT, which is vertical line test, and is therefore a function. Okay, now I'm going to show you how to use the vertical line test, but I'm not going to explain it till we get to the examples we're going to do together. So here's what you do. Here's how the vertical line test works. You don't have to write this down. Again, we're going to do a whole bunch of examples together in just a minute. So the graph that I just had drawn, you don't have to draw this. I just had a graph that looked like that. Now, what I'm about to do is I'm about to use the vertical line test. Here's what you do. Take your pencil or do it in your head and draw as many vertical lines as you want to. For instance, there's a vertical line. Go all the way across that graph, draw vertical lines. If every vertical line you draw intersects the graph at most once, that means no more than twice, 2 or more times. As long as if it doesn't touch it, it's okay. If you draw a vertical line and it touches it once, that's okay. So this graph passes the vertical line test. So that means then that this graph is a function. Now remember, what does a function mean? It means the x's don't repeat. So here's what that means. If I wrote out every ordered pair on this graph, which I can't do because there's millions, but if I wrote out every ordered pair on this graph, every one of them would have a different first number. None of them would have a same first number. In other words, the x's don't repeat. This is just a quick way to do it. But if you can draw one vertical line that touches the graph at 2 places, it fails the vertical line test, and it's not a function. Now, once again, when time comes, I'll explain why the vertical line test works the way that it does. Bottom line is, you just need to know how to use the vertical line test. Okay, so here's what I'm about to do. I'm about to put up about 6 graphs, And you'll hear me say, pause the video, and you just copy the graph as it is. Make sure that you copy it exactly as it is. And then after you get all of the graphs copied, we'll back up and do domain, range, and graphs. Let's go ahead and write the instructions to these. Here's the instructions. For the following graphs, state the domain, comma, range, comma, and determine if the graph represents a function. Okay, so now, about to put up example number 1. Make sure that you've got, can see it all first. Let's see here. Okay, pause the video now and copy this graph. Okay, you should have that one. Pause the video again. Copy this graph. Okay? Graph number 3. Hold up before you graph number 3. I've got a little marker mistake on it so that you can fix it. When you draw this graph, when you draw this loop around here, I accidentally dropped it too low. Don't copy this part right. It's not forked. So don't copy that right there. It's just that one little shape. So ignore that right there. Okay, copy that. Okay. Number 4. Copy this graph. All right, and then number 5 is the simplest of graphs. Is this graph right here. Copy it. Okay, so you should have all 5 graphs now. So just kind of sit back and watch me while I talk about this. It's pretty easy now if you remember your notes. Okay. Domain. What is domain of a graph? It's how far the graph goes from left to right. All right. Over here, there's no graph because this doesn't have an arrow on it. So this graph starts right here. Now, look at that first X number right there. It's -1. And the reason I put this here so you can see where it's supposed to be. So your first number in that first ordered pair is -1. Now, how far does it go right? So it goes right until you get to over here, to that X number here. So the domain is all the numbers from -1 over to +4. That's how far the graph goes from left to right. And it has to be in that order. Now the range. The range is how far the graph goes from the bottom up to the top. Well, there's no graph down here. The graph starts right here as far as the floor. That's at -2. Now, how high does it go? It goes up to here, up to 3. So the range is how low the graph goes to how high it goes. So that's from -2 up to 3. Now, does this graph pass the vertical line test? Yes. You draw as many vertical lines as you want to. I don't care where you draw them. That graph passes the vertical line test. So, does that mean it's a function? Yes. So, is it a function? Yes. But again, go ahead and say why. Passes vertical line test. Okay? Now this next graph. This next graph, how far the graph goes from left to right. Okay, so the graph starts at the left, starts right here at -4. Now, how far does it go right? What does this arrow mean? This arrow means two things. Number one, it means it goes down. We're not talking about up, down. We're talking about left, right. So, how far does this graph go right? It goes to the right. It never stops going right. It's going down forever, but it's also going to the right forever. So this graph doesn't stop going right, but it starts right here. So your domain now is from -4, and if it doesn't stop, what do we call that? Infinity. Now let me say again, that infinity doesn't mean because it's going down. That infinity means because it's going to the right forever. Now the range. The range is how far the graph goes from the bottom to the top. It has to be bottom first. All right, does this graph have a bottom? No, it does not. So the bottom now, since its bottom is negative infinity, now does it have a highest point? Yes, it does, up at 3. So the range is from negative infinity up to 3. And is that a function? Yes, it passes the vertical line test. Okay, now let's look at this one. Domain. Domain is how far the graph goes from left to right. All right, there's no graph over here. The graph starts right there. There is, look at the x-axis, is at 1. Now, how far does it go right? Well, if you travel this path, it goes from 1 to 3. But if you travel this path, it goes from 1 to 3, but it keeps going on. So I'll have to use the longer of the two paths because this path includes these numbers, 1 to 3 and then 1 to 5. So just say from 1 to 5 because that includes 1 to 3. So the domain is from 1 over to 5. The range. The range is the lowest point, y value, not x value. Lowest point on the graph, which is at 0, to the highest point, which is at 2. So 0 to 2 is your range. Now, does this graph, does it pass the vertical line test? No. If you draw a vertical line right through here, you're okay over here. You're okay right here. But if you draw a vertical line right through here, remember every vertical line can only touch it at most once. So if you can find one vertical line that touches that graph more than once, it fails the vertical line test. So if I do my vertical line test right through here, it fails. Now I will explain why. Watch what happens when I draw this vertical line. It touches right here. What is this ordered pair right there? It's 1, 2, 2 comma something. But look at this point. It's 2 comma something. But it's 2 comma something else. So see, you've got 2 points on your graph that's 2 comma something, 2 comma something. What does that mean? It means your x's repeat. That's why you use the vertical line test. If you draw a vertical line on a graph and it touches 2 places, it means those 2 ordered pairs have the same first number. And remember, with the function, x's can't repeat. So that's why we use the vertical line test. Now, you don't have to say all that. All you've got to do is say, yeah, no, it fails the vertical line test. Okay? This next one. This next one, the domain's a little different. How far does the graph go from left to right? Well, what does this arrow mean? It means it goes up forever. We're not talking about up and down. We're talking about left and right now. So, how far does this graph go to the left? That arrow means it goes to the left forever. If you go to the left forever, that's negative infinity. Now, let's see how far it goes right. All right, start tracing the graph. It goes to right here, but then there's a break. Now, what is this x number right here? It's 0. So it's from negative infinity to 0. But then there's a break in the graph. Then it picks back up at 3 and goes from 3 over to 5. from 3 to 5. So the domain has two different intervals. Negative infinity to 0, union 3 to 5. Notice two things here. First, remember you never put a bracket with the infinity. I'm putting brackets on these because you're including those numbers. Now, the computer may not want to require that you put a union symbol. It may just let you put a comma in between the two. But this graph has two different sections of domain because it uses two different sets of numbers because of the break in the graph going from left to right. All right, now let's do the range. The range is how far the graph goes from the bottom. That's at negative 3. That's the lowest point on the graph at negative 3. Now, how high does it go? Well, if you go from here to here, it goes up to 2. But if you go the other path, it covers all of these. So 0 up to infinity. I'm sorry, negative 3 up to infinity. Negative 3 up to infinity. Now you say, Mr. Randall, what about these y values right here? These y values right here, remember bottom to top, these y values right here are absorbed in this piece and this piece also. So that covers all of those numbers. And yes, that's clearly a function. It passes. I don't care where you draw your vertical line, you won't find a vertical line that touches that graph twice. Now this last one is the easiest, really, of all of them. The domain is how far the graph goes from left to right. This graph goes from negative infinity to the left, to the right forever. Negative infinity, positive infinity. The range, it goes down forever and up forever, and there's no breaks. And is this a function? Clearly that's a function because it passes the vertical line test. So all of the circles we did, a circle can never be a function because it fails the vertical line test every single time. All right, this concludes remember we were going to do ordered pairs, then we're going to do graphs. We just did that. Now we're about to move to equations, and that will be our third video in this section.